When you start with the right triangle, that is the 3, 4, 5 triangle, and you draw the largest inscribed circle inside that triangle, it turns out that circle has area exactly pi. And that is because that circle has radius exactly 1. So let me ask a number of questions related to this, and then I'm going to give the answers to those questions. Suppose I have a right triangle that is actually given with side lengths a, b, c, so those will satisfy Pythagoras' theorem, a squared plus b squared equals c squared. And here are some of my questions. Is the radius of the largest inscribed circle always an integer, or is it sometimes a rational number? Is it sometimes an irrational number of some sort? Can you come up with a formula for the radius in terms of a, b, and c? Can the radius be exactly 1 for other Pythagorean triples? Are there infinitely many Pythagorean triples where the radius is exactly 1? Also, is any radius possible? So if I give you another natural number like 17, is there a Pythagorean triple that has an inscribed circle of radius exactly 17? Or given n, any natural number n, is there a Pythagorean triple with radius exactly equal to n? I'm about to answer all these questions, so if you want to think about it, stop the video here. The first important fact is that yes, there is a formula for that radius. I'm not going to prove it here, but it turns out there is a beautiful formula for it because the radius is exactly a plus b minus c divided by 2. That formula alone tells me that if I have a Pythagorean triple, then the radius will be a rational number. Because of the divided by 2, it's not clear that it's always an integer. So let's do some more work to prove that it is in fact an integer. Another important fact is that the Pythagorean triples can be parametrized. So every Pythagorean triple can be written in this way. For some m bigger than n bigger than 0, a, b, and c will be given by m squared minus n squared, 2mn, and m squared plus n squared for the hypotenuse. And now combining the formula for the Pythagorean triples with the formula for their radius, I can compute a formula for the radius in terms of m and n, because I can plug in a plus b minus c divided by 2, plug in the values of a, b, and c, simplify, and realize that the radius is just n times m minus n. Since m and n are integers, the radius is always an integer. Now, back to my original questions, when is the radius exactly equal to 1? If it's 1, then n times m minus n would have to be 1, so both n and m minus n have to be 1. That means that n is equal to 1, and m has to be 2. And that corresponds to the Pythagorean triple 3, 4, 5. So there is only one case where the area of the inscribed circle is exactly equal to pi. And for my other question, if I want any possible radius, I can do the following. I can take m to be n plus 1, I can take n to be any natural number, and then in that case, r will be exactly equal to n. And that means that any radius is possible. So if you want radius of 17, I can take the Pythagorean triple that corresponds to n equals 17 and m equals 18, and that will give me a Pythagorean triple and a triangle such that the radius of the inscribed circle is exactly equal to 17.